the agenda for this talk is like that. So first we will give you a brief overview about the Spring Data portfolio itself. So what do we offer? What do we provide? I will quickly explain our new approach for doing releases and of our versioning scheme and give you a real quick refresher of what Spring Data is about. Then we will cover some of the core themes and their common features of the store modules, for which we will go over some enhancements really introduced into the recent releases, and we will conclude with a quick outlook for what will be in the next upcoming release in Gosling. But before we start, maybe a quick show of hands. Who of you is already using Spring Data in some way? Okay, almost all of you, but I see some hands down. Okay, that's great. So let's start with the overview for those of you who are not yet using Spring Data. So the goals of Spring Data is to provide a uniform and easy way to interact with all kinds of data stores. So to make it easy to interact with relational databases, with document databases like MongoDB, graph database, and the like, in a very uniform way, so that you don't have to change that much code if you want to switch the way you store data, for instance. We provide a bunch of reusable abstractions that makes it easy to interact with that stuff. We have support for the repositories abstraction, which comes from the domain-driven design space, which makes it easy to interact with data stores in a fluent way. We will basically make you write less boilerplate code for your persistence layer. We're almost, for many applications with Spring Data, you actually don't have to write any custom code yourself at all to get the basic CRUD functionality for your persistence layer working. And we support a wide variety of persistence models, be it graph storage, document databases, and the like, so which we will see in a bit. And we enable you to use store-specific functionality when you need it, but if not, you can stick with the common functionality which works across many stores at once. So, please meet the Spring Data family, which is nowadays comprised of the following core modules. We have this Commons module, which contains the core functionality and the common abstractions, and many store-specific modules like for JPA, MongoDB, and Neo4j, Solr, and Gemfire, or in-memory data grid. We have a REST abstraction there, and of course support for Redis. But that are not the only modules that Spring Data provides. We also have some community modules, like for instance support for Couchbase or Elasticsearch and Cassandra. And besides that, there are many more. There are some not that well-known repository abstractions, for instance, for JDBC repositories that basically give you all the power of Spring Data repositories just based on plain JDBC template of Spring. And we also provide, there's also a Spring Data RDF project around, RDF for this triple stores that you can query with Sparkle and the like, so that you can do semantic web-like stuff based on Spring Data repositories. And we also there's also Spring Data Nverse, which provides basically versioning support and auditing support based on Hibernate Nverse. So just that you are aware of that. Okay, we have some projects in incubating stage, which are currently the Create.io document store, so to speak. We have an incubating Spring Data project for Aerospike, also some kind of key value store similar to Redis, but with more richer query capabilities. And of course for Hazelcast, an in-memory data grid in this case. So now that we have seen a quick overview of the modules that are there, let's quickly talk about a big change that we recently introduced, which was about versioning. Because as you have seen with the Spring Data family, Spring Data is not a single project, but rather it's an umbrella project that is comprised out of many modules, which are each versioned independently. And we figured out that this caused some confusion for some users, because they had a hard time figuring out which version of which module work well together. Right? Especially in a bigger projects where they have multiple data stores to serve, and it could what's sometimes a bit of a pain for the users to figure it out what works well together. And so we sat down a bit and thought, well, what can we do to ease that a bit, to make it easier to find the correct working versions? And the solution we came up with was the adoption of a new approach to doing releases. Namely, we do a release train. We took a release train approach, like the one that Eclipse does, to release many modules or many projects at once in a coherent manner that all dependencies are somehow aligned and harmonized. And yeah, this helps us really coordinating the development of the individual modules. And yeah, the release train is for about eases our release coordination efforts. It ensures compatibility between modules. It helps to avoid to avoid confusions with the different versions which are out there, and gives you an easy way to refer to a set of functionality via one single canonical name, as you will see in a second. And as I said, it's similar to the Eclipse release model. And to give you a quick overview of the releases we did so far, we name our releases after famous computer scientists, which is our way to honor those great minds on whose shoulders we stand every day. So it's like, start with Aurora, Babbage, go over to Cord, to Dijkstra, to Evans, and Fowler, which is our current GA release, and the upcoming release will be called Gosling. So what are these names now about? How do you use that? How do you refer to a release train? Well, for that, we have this so-called BOM. BOM stands for a bill of materials, and is basically just a collection of Maven dependencies that are somehow weaved together, and you can refer to that set of managed dependencies, so to speak, via one single canonical name, which is in this case for the latest version Gosling M1. So if you want to run with your code with the latest Spring Data stuff, just define a dependency to this BOM Maven dependency, and you get everything as a managed dependency there, and then you can pick and mix and choose what you want to use. Spring Data JPA, Spring Data MongoDB, and the like will all be provided for you then. And yes, as said, important part is artifact ID, Spring Data release train, and refer to versions Gosling M1. Okay, now let's quickly walk through some core concepts and core abstractions. The most important abstraction that we provide are Spring Data repositories, which gives you basically, as said, a pragmatic data access API. It is built on top of an interface-based programming model. So, as said, for your persistence layer, or for large parts of your persistence layer, perhaps, you don't have to write custom implementations. Yeah. So it's not required, but if you need them, that's possible, and I will show you in a bit how you can use that in combination with the interface-based approach. So, as said, we provide some base abstractions like a base repository interface. It's just an empty marker interface that triggers some special behavior of your repository components, and it also allows you to define, use a mechanism called query derivation. We will see that in a bit. We also provide this CRUD repository, which effectively gives you all that CRUD functionality that you would otherwise need to write by hand yourself, which is just plain boilerplate code most of the times. It's functionality like find all, save a single entity, save a bunch of entities, delete an entity, and find an entity by ID, and so forth, right? All that CRUD functionality is be given to you for free without having you to write a single line of code, right? Just by implementing that interface. We also provide some sophisticated support for pagination and sorting, which you can use by just extending your repository interface by paging and sorting repository, and that's it. And of course, we provide some store-specific variants like a JPA repository, Mongo repository for special scenarios where you need to access data store-specific functionality, which we generally don't recommend. So you should really only use store-specific base repositories as if you really need them, because it makes it harder to switch data stores once, right? If you stick with some generic functionality like CRUD repository or paging or sorting repository, you can easily switch normally you can easily switch between, for instance, a data store like JPA-based or relational database-based data store and something like else like MongoDB, for instance. And we also got customers that actually do that, right? So it's cool to be able to. Okay, there's one interesting mechanism there that we support, which is query derivation. So which basically allows you to generate queries from method name conventions. Well, how does it look like? Well, it looks like that. So in your repository, you define a method like, okay, return me a list of users, and the method is called find by first name and last name. I give it 2 parameters, and out of that, only out of that mechanism, out of that method, we generate this query for you, right? That you would otherwise have to write yourself. And it works by, as said, following a certain set of conventions. We have a list of keywords that triggers some special behavior, and and we map the properties of the entities that are associated with the repository. We will detect them in your finder methods or in your query methods and make sure that they are present. And we also have some tooling in Spring Source Tool Suite, for instance, that warns you if, for instance, you have a typo here and there is no first name property in the user class, for instance. Right? It will mark that place with a big red arrow, and so that you are aware, okay, I had a typo and I had a problem there, and so forth. And of course, it automatically binds the parameters to the right places as you specified here, right? We use bind variables here and the like. So it's all pretty efficient in that case. So, but we also have support for so-called defined queries, which basically gives you the opportunity to externalize the queries or specify the query yourself, either via the query annotation, which looks like that, or via an external lookup mechanism. So basically, if you just add the method with @query, for instance, without specifying a query string yourself, there is either a properties file or a properties file convention, naming convention that we follow to look up the appropriate query by the convention of the entity name, in this case person dot find by first name and last name, right? And that is a great mechanism to externalize your stuff so you can change the query without actually changing your code. We also leverage data store specific ways of storing such queries, like in case of JPA, we also consider named queries that are stored in the orm.xml file. So that works in the same way, right? So you have ways to customize that. We also have ways to express more flexible queries. So you can imagine that, okay, if we have this method name convention, we follow this method name convention, but if I have a very flexible query model, I would come up with thousands of such finder methods, right? Which could bloat up our code quite a bit. So in order to remedy that situation, we also provide support for a library called QueryDSL. Who of you has heard of QueryDSL yet already? Okay. Yeah, QueryDSL is basically allows you to do type-safe queries for Java. It does that by basically analyzing your annotated domain model and generates a query model in parallel to that, so that you can say, for instance, it generates classes also with some prefix, like, for instance, for a class user that has a first name property, it would generate a QUser class, where you could say in a query, find by, and then find all by, and then you say QUser dot first name dot for equals some string or something like that. And based with this on a fluent interface, it will help you to generate basically arbitrary predicates that can then be used to limit or restrict the queries and so forth in a type-safe way. So you can't do any typos there without a compiler complaining about it. So, and in order to use that, all you have to do is just also extend your repository with QueryDSL predicate executor. And okay, here's an actual example for how you watch a CRUD domain-specific repository could look like. So in case of if you want to store persons, all you had to do is just say, okay, I define an interface, person repository, extends CRUD repository of person, this is the entity type, this is the ID type that's associated with it. So that's all you have to do, and now you can go on in your Java code, Spring code, and say, add auto-wired or add inject person repository somewhere, and you will basically get a proxy that is implementing that interface, and that has all this find all, save, delete, and what have you methods available for you. And the implementation is backed on some default implementation that we provide, right? So that's the general mechanism how it works. And but as I said, sometimes there are situations where you need to write custom implementations for query methods, right? If, for instance, if you want to have a very performance critical thing and the generated queries are not fast enough, or you want to do something else, you can provide your custom implementation for that one particular method or a bunch of methods, which works like that. You define an additional interface. It's based on a naming convention, which is of course configurable. You say, okay, I have a person repository here. I want to add custom functionality. Therefore, I define another interface called person repository custom. And there I define my custom operation, which could do a batch operation or what have you, callers.procedure or something like that. In addition to that, you define an implementation class, which is, in this case, your person repository implements your custom interface. You implement your data access logic as you want to be, and here you can do all kinds of things that you normally do with Spring. You can say add auto-wired, JDBC template, and what have you. You can use everything that you're used to do to implement your persistence logic. And the last step is you have to add this interface, this custom interface, to your repository interface in the action source, and that's it. And again, if you say in your code add auto-wire person repository somewhere, you get all the base CRUD functionality combined with your custom operations. So it's all at your fingertips, and you don't have to, write that big amount of code to get that working. So, well, that's it for the introduction. This is just a brief overview of the features that we ship with Fowler, or not all of them, but some highlighted here. For instance, I will briefly go over them. One major theme was, for instance, to improve our Java 8 support, which we did in various ways. We supported optional Java 8 streams as repository return types, and but let's waste time here. Just let's go over to the stuff. For instance, for Java 8 streams, we support that currently for JPA and MongoDB. Others support for other stores are in pull requests already. So if you want to use streams, it basically looks like that. You have your person repository, and you just say, okay, return me a stream of persons. That's it, right? And the same works, of course, for queries. And now you might be wondering, well, how do we use that? Because JPA doesn't offer streams, right? How do we use that? Well, it turns out that some JPA providers, like Hibernate or Eclipse Link, and effectively also OpenJPA, provide internal APIs to get at the data of the result of a query in a streaming fashion, right? And actually, that's what we do. We hook into these internal APIs, or store-specific APIs, and in the case of Hibernate, for instance, we use Hibernate scrollable results in order to back up this streaming mechanism. And with that, you can effectively stream big amounts of data via Java 8 streams. And we will only fetch the data while you traverse the stream. So it's not we load everything up front and then you get a list and work on the stuff yourself. You can get this result one by one. And one important thing here is that since the stream encapsulates these internal structures, you have to make sure that you close that on your own, right? So you have to use a try with resources block around that in order to interact with that properly, right? To make sure, okay, at the end, when I'm done with the interaction, I can close it. So, and that works, as said, also for MongoDB, which is, even there, we didn't have to do that much magic as we had to do in JPA to make it work. So it's also a good way to deal with big amounts of data in a lean way, so to speak. So we also had some improvements with the slices and pages, which now support some kind of mapping operation, so that you can easily convert data that's wrapped in a page to some other form. For those that don't know those abstractions, page is basically the result type of our pagination mechanism. So in general, our pagination mechanism works like that you have a finder method, and you on your interface, and you add a special parameter type, for instance, a page request, or pageable is the interface as a parameter there. And there you can, if you call that method, you pass it a so-called page request. You say, okay, I want page 13 with page size 50, for instance, right? And we will, under the covers, generate an appropriate query that does the pagination for you in a proper way. Okay, the result of that finder method is a page, and the page contains information about, okay, the actual results that came back for that page. It comes back with the information whether there's a next page and how many results are there in total, right? And yeah, maybe that's another thing. In order to get that information, how many results are there in total, we actually issue two queries for pagination query, which is we query for the actual data and for the count, which could be problematic in some cases, right? Because, well, maybe sometimes I'm not interested in the total number of elements that are there at all. I just want to know how many pages are, how many elements are currently there, and whether there's a next page or not. And for this mechanism, we introduced a more linear structure, which is called slice, which is basically the base class now of page. A slice gives you the same information as page does, but it doesn't trigger the additional count query. It just tells you whether there's one more item in the results available or not in order to generate a next page for a catalog or so if you want to browse something. Okay, there was a question?
In terms of paging, do you optimize the second count query? Because in case of databases that use multi-version control from CC mechanism, it's really expensive because you cannot use indexes, you have to do full table scan.
Yeah.
So do you optimize it per the database that is being used?
We use data store specific means to do this count mechanism. We have no special optimizations here, but since you can configure the count query, that should be done yourself in addition to that. So even if you use query derivation, or if you define the query that should be executed yourself, you can also define the count query that we should do. And with that, you have the flexibility if you want to do this yourself.
Count query would be used
In the pagination mechanism. Yeah, right. So you can customize it, of course.
Okay.
So, but if you have suggestions for optimization that we could do here, just feel free to talk to us or raise an issue in Jira, and we can see what we can do about it. Okay. Yeah. As said, okay. Here, page. You get a page result of persons, or in this case, strings, and with this converter interface, yeah, you can basically convert that to some other representation, which is then executed for all the records in the page. So we also support JSR 313 and the 310 backport for new datetime structures in repository in the parameters of your queries, and of course in the entity attributes. And yeah, so it's basically those types are all now also supported, which weren't before. We also enhanced the QueryDSL predicate executor a bit, so that we introduced new exists and find all methods that accept a predicate, which basically looks like that. That was the QueryDSL predicate mechanism I was just explaining before. So you define a method, find all, added a predicate parameter there, and you have optional order specifiers where you can also specify ordering in a type-safe, fluent interface way. And yeah, that's basically how it works. Repository find all, person, date of birth after today, person, first name, ascending. As you can see, no more type errors, no more typos here. Yeah, same for exists, which makes it very handy to work with that stuff. One major theme of the latest Fowler release was also to introduce some performance tweaks, where we found that we were not performing as well as we could do. So, for instance, here are some performance numbers from the previous release, Evans, and with some changes that we did, we were able to achieve much higher, much better performance here. There's a benchmark in the repository available if you want to try it yourself. This one particular example was run on a Mac Book Pro, in this case 2.6 gigahertz and 16 GB RAM. And but maybe the numbers are not that important. Maybe it's more interesting how we achieved that. And we found out that, for instance, for MongoDB, one big performance, not bottleneck, but performance killer was reflective instantiation of result objects, right? If you ask for 1,000 person records, you get 1,000 instances of a person, right? All reflectively instantiated, and that cost a lot of time. Even though after so many 1,000 invocations, the JIT compiler eventually could kick in and so forth, but it was still too slow. And the way we solved that problem was basically by dynamically generating factory classes via ASM, the bytecode generation, and we just generate appropriate factories that have an implementation, create instance with some parameters, and internally just does a new something, right? New person with that arguments in the constructor. And we found out that this gives us a 20 or sometimes 50x improvements in dynamic instantiation. It's if someone of you want to look it up, it's the bytecode generating entity instantiator. We found that Hibernate has a similar approach internally, but this is disabled by default. So yeah, we added basically the same functionality again in order to be able to use it in Spring Data JPA, MongoDB, and all the other stores to make them faster. Yeah, and of course there's more. We have some special support for, we added a not containing keyword as a list to the list of keywords that we support currently for the query derivation mechanism. By the way, if you're interested what keywords are available at all, if you Google for Spring Data ref card, there you find a nice PDF that lists all the keywords that are available for you to use. And yeah, there you can see, get a good overview of what you can do at all with that. Okay, we improved some internal stuff, cache lookups to make it faster. Okay. We introduced for MongoDB spatial queries, for instance, we introduced a range value type, or very generic structure, general in Spring Data Commons, that is mostly used in Spring Data MongoDB, that allows you to do geospatial queries in a sense that I want to find objects with a minimum distance and a maximum distance, so in a range somehow. And yeah, this makes it really easy to do some geospatial searches in this case. We also improved the way we can configure transaction behavior in the case, for instance, of extended persistence context in JPA. So we ensured that if you want to control the transactions yourself, you are now finally able to, which was not possible before. So maybe let's go on to some store-specific enhancements in the store modules. For instance, for JPA fetch graphs. In the JPA 2.1 specification, they introduced a way to specify how the fetching and lazy loading is done for your entities. So, and let me see, the way it's used. These are, for instance, plain JPA annotations. So all this annotation bloat you have to add to your entity class. And then you can, in your finder methods or in your repository methods, which you can override here, you can basically refer to them and somehow customize or select the predefined fetching behavior, right? It's about which attributes do I need to be fetched for that particular query task in this case, or whether something should be is lazily. For instance, if you have just an overview listing, I don't need to load all the details, right, for an entity often. Right? But this turns out to be quite cumbersome. And in the recent release, in Gosling release, we found another way to get even rid of this annotation bloat here. So, but I will tell you that in a second. Another enhancement that we did was spell support in queries. So basically, just as an example, what you can do. So for instance, if you want to be able to write generic queries, you can use spell expressions within that. So for instance, we provide some default variables that you can use. For instance, hash entity name is replaced with a person or the entity type that you specify, the simple name in this case. And yeah, you have some means to process the incoming arguments via spell expressions. You can call arbitrary methods on them and so forth, so you can manipulate the actual parameter that is then bound to the result, right? To the actual event, to the query parameter that you want to use. Here's an example for using positional parameters, but we also support name parameters in that case. So here, for instance, the parameter is called pageable, and you can refer to it in the spell expression via the hash pageable name in this case, and you can access some properties here, as you can see, right? This is just a monstrous example how far you can go. But the most important use case for that is to use spell expressions in your security for filtering data based on the current security roles as a user has. For instance, here you can say, okay, I want to define a method that returns all the objects a user has access to, so to speak. In this use case, I want to allow an administrator to see all persons, but a non-admin user should only be able to read his own user or to see his own user, right? And that's one way to do it, right? You have a spell expression that simply returns the appropriate filter parameter here, right? And with that, you can, do all kinds of tricks. And another variant of this looks like that. So if you, for instance, if you don't have an attribute that you can check for, you can simply do something like that. Okay, just check where the person ID equals the principal ID, or you have another way to express a wildcard, like, right? If it is a role admin, this condition will always, this expression will always be true, and if not, it will false. It will render the whole expression false, and therefore nothing will return for other users then, in that case. Yeah, just as an example. Some performance improvements. Yeah, we avoid query creation for page execution if we determine that the count, that there are actually no records there, so we don't trigger enough additional query that would return nothing. We finally honor Java persistence version to do checking whether an object is new or not. We also support now the usage of composite keys together with find all and find one and so forth. We have also some support for stored procedures, and which we actually shipped with the previous release already, but we now also support to return data via the in Spring Data and JPA a ref cursor, which effectively gives you the opportunity to in a stored procedure to return a list of results, right? Return the result of a query that you do in your stored procedure. That's software is good to be able to implement legacy functionality. Yeah, and some more stuff. Let's go over that. Okay, MongoDB. There, one important task was to ensure compatibility with the latest developments in MongoDB. For instance, the current version of MongoDB server is 3.0, and there were different versions of the MongoDB driver which had some issues with the latest versions. So we had to figure out, okay, what is the right set of MongoDB server and MongoDB Java driver that we support that actually works for us. And we decided to just focus on those here to be able to, support the recent versions of Spring Data MongoDB. And that are actual versions we run our integration tests with now and where we do all the continued development on. Yeah, that's basically it. And by the way, MongoDB in version 3, they introduced a new storage engine, which is called Wire Tiger, which you have to explicitly turn on. And we run all our tests also with that different storage engine, so that we make sure it works in every case. Okay. With that changes in the used driver version of the MongoDB Java driver, we also deprecated some ways to do configuration. For instance, this way, which was used before to configure MongoDB clients and so forth, or connection, is now replaced by that approach. If you have still XML configuration lying out there somewhere, Java config looks similar. And yeah. Just as a side note, the upcoming Gosling release will provide more sophisticated support for MongoDB 3 features. For instance, the full-text search capabilities that have been included there and the like. We've also added some enhancements for the geospatial queries, which we now support to use GeoJSON types. So, for instance, looks like that. So you can say you define a domain object like a store if you want to build a store search for the nearest store or something like that based on MongoDB. You can, in the domain model, you can then say, okay, this point is geospatial indexed, right? And it will, at startup, check whether the index exists or not, or if not, we will create the index for you. And currently, we also support this legacy coordinate format in this old style. And this was a big pain point for us because these GeoJSON types are somehow, or the new geotypes in Mongo were incompatible with the previous ones. So we had to do pull out some tricks in order to make it work for all versions. And yeah, so therefore we introduced basically dedicated support for the new GeoJSON types in order to make that work, which basically look like that. So that's we have just changed the package. The names are effectively the same, so that's quite easy for you to change to the new types. Just change the package name, and most of the time it just work that way. And with that, we are able to use all the latest and greatest stuff that's provided to us by the underlying MongoDB Java driver. Okay, what else? Let me just go over. Yeah, this was the example. We have also here's an example where the class name actually changed, GeoJSON point, to make it explicit that this is a GeoJSON point in this case. And yeah, it will then generate the stuff in a new format. Yeah, let's just skip over that because I don't have that much time. Okay. We also support now to execute server-side JavaScript via MongoDB, which basically works like that. You define your script as a string. You can also refer to MongoDB objects within there and interact, ask for collections, query collections, what have you. The way you execute it is that you, on the Mongo template or Mongo operations, you say, give me the script ops, and you then say, execute the script, and here is the parameter that you want to execute. And yeah, that's basically it, how it works. What else? Yeah, we added some additional functionality in the query operations, like, mol, we can check for bit positions and what the like. And for update queries, of course. We now support min distance for GeoNear. Yeah, that comes together with this range support that we introduced. Yeah, we had some issues with translating some keywords in the repository finder method correctly, which is now fixed, and we also provided some means to do faster insertion via Mongo repository insert, which previously did some additional version checking that sometimes you didn't need. And if you wanted version that does all the other stuff, like checking for versions and the like, you just call a Mongo repository.save. If you want to do just bulk insert, then just use Mongo repository insert, which was available on the Spring Mongo template or Mongo operations interface for quite a while. But we also now exposed it to the repository API so that you can use it there as well. Okay. It's basically a list. For Redis, one big thing that we added to Redis is support for the data structure called hyperloglog. Does anyone of you know what hyperloglog does already? No? Okay. Just for those that don't know, hyperloglog is basically a data structure effectively that gives you the possibility to get an approximative cardinality estimate of a set. So imagine if you want to collect, if you want to know how many distinct items did I see, or do I have in a set, or did I see in a set, you usually store everything in a set and then ask it for the size or the count, right, or for the cardinality. The problem with that is, if you want to count huge number of items, you quickly run out of memory, right? And this hyperloglog data structure uses some probabilistic tricks to give you just an approximative estimate, which is nevertheless in a with high accuracy, but available, but with a fixed amount of memory that you can configure. So you can configure the accuracy that you want, that you need, and it will only use a fixed amount of memory. So you just feed it some data items. So in Redis, it works like that. This is the name of the hyperloglog structure where you want to store your stuff. You feed it some values. You ask it for a count, and for small number of items, it will give you the right answer. But for certain at a certain threshold, it will be approximate. And yeah, you just add more items. You can merge several counters or merge several structures to get a union of that, or the difference, and so forth. And you can ask it for the complete count again. And the way we support it in Redis is via the Redis template. You just say ops for hyperloglog, and you just say, oh, okay, hyperloglog ops.add, and where you want to, you specify where you want to store, and you send it some items. You can ask it for size, you can union some stuff, and so forth. And that's really convenient if you just, want to check for a rough estimate of how many things you saw, or how many different users you saw for something, right? Or how many different products someone watched, or what have you, right? Without having to store the actual thing. Okay, Gemfire. We revised the cluster setup there. So basically, previously you had to set up the cluster configuration up front on every node, so that you know that so you have to know about the actual cluster setup. And now we introduced capabilities to read that configuration out of the cluster itself, so that you don't have to use the specific cluster configuration on every node. We will pull that out. We will figure it out for you automatically. Okay, some enhancements in the Spring Data REST projects. We added support to generate e-tags out of by considering or honoring the information that we already got via the, for instance, JavaX persistence version attribute in this case. So, just as an example, for version 1, if it was the first version of the customer that was stored, we will also propagate that information to the REST interface or to the HTTP response that we return. We also honor the last modified date now that is associated with that JP entity, for instance, and yeah, it gives you the real last modified date from the database when the data was lastly manipulated or so forth. So that's now done for you. You don't have to do it yourself again. So we also provide some support for JSON schema, or that JSON schema is exposed in some way via the ALPS endpoint, which stands for Application Layer Profile Semantics, which gives you basically a rough description in some way of your applications and the available links and the names for the particular subcomponents in your REST API. And yeah, we now offer this schema endpoint, so to speak, that gives you access to the JSON schema of your REST. So you can use that to build self-describing REST APIs, so to speak. Okay, now the next point is Solr. We introduced support for a feature called real-time get, so you can basically read uncommitted changes before the indexing is completed yet, but for objects that have already been passed on to Solr, which effectively works like that. You say you save something you want, but you want to don't index it for some reason immediately, you can say, if you would say query for object in the regular way, it will not, via the Solr template, it would not return the document yet because it has not indexed yet completely, but a getID call would return it. And that's the point. A real-time get only works by ID because, yeah, since it has not been indexed yet, you can't search for it another way. So, and other stuff that we did was to provide support to access the information about the relevance of a search result. For instance, if you have an entity, which is underneath a Solr document, to store it in Solr and to retrieve it later, you had to provide a custom field, which has to be named stored, or you could remap the name for somehow. But for the query, you had to explicitly state that you, besides all the other fields, I also want to store the internal information of Solr in order to retrieve the relevance of a document, right? And this was a bit cumbersome, so we decided to make this easier. So instead of having to write this bunch of code, you can now just say, okay, add score. You can mark your own field as you wish with the add score annotation, and you don't have to express it here anymore. We will detect that annotation from that entity, and we will do the right thing that provides you with that relevance for that. So where's the code for that? Well, you find that in the Spring Data examples repository on GitHub. There are, for all data stores, we provide examples that show the latest and greatest features through all releases. So if you are looking for some particular feature, you will find it there. But okay, there is of course more. That's not all that I wanted to show you. I showed you earlier that the way JPA fetch graphs are supported, right, or were supported in Spring Data repositories, were a bit cumbersome because it relied on you specifying the fetch graph configuration on your entity up front, right? Which could lead to a decent amount of boilerplate on your entity classes if you really want to move it use it extensively. And again, we figured out an alternative to that, which looks like that. We just say, again, just entity graph, but instead of referring to the entity graph you annotated on your domain model, you just specify the attribute paths that you want to, for instance, eagerly loaded or lazily, or via fetch load mechanism and so forth. And you can specify that here as another attribute as well, whether you want to have load or fetch behavior in this case. And that's all you need to do. We will generate the necessary JPA fetch graph stuff underneath for you dynamically. So you have now a declarative way right on the method where you need it to express that stuff without writing a bunch of annotation boilerplate on your entity annotation. So, and again, no need for a named entity graph annotation entity. And yeah, that we support on all persistence providers. We support the Spring Data JPA, like OpenJPA, Eclipse Link, and Hibernate, of course. Okay. Another change that we did in Gosling, or that we are doing in Gosling, there's currently a milestone 1 release out there that you can already try, which is about providing functionality or custom functionality to all repositories. Previously in the introduction, I showed you that it is possible to implement some repository methods yourself if you need it. But what if you want to be able to add one custom method to all your repositories, or a bunch of custom methods to all your repositories that you want to use in all your repository interface of some kind, like JPA repositories or and the like. That's now easily possible. So it works like in the following way. You define again a repository interface, my repository, where you list all your custom method declarations that you want to have. Then you define a new repository base class, so to speak. So currently all JPA repositories are backed by a simple JPA repository. And you just extend that, implement your custom, your my repository interface with your custom method, implement that, and then you say in the configuration, add enable JPA repositories, but now use the my JPA repository class as a repository base class. And it will automatically be picked up by the Spring Data repository infrastructure, and will automatically provide that your implementation as the backing class for all other stuff. You can, of course, also use that way to change the behavior of Spring Data, of this common functionality like find all and the like if you want, right? So it gives you an easy way to customize what we do by default. And this is possible, this is available throughout all other stores. So if there's functionality that does not do what you want, you can, of course, totally customize it. Okay. Another thing that we are currently working on is support for completable future, which gives you an asynchronous execution model. And it basically looks like that. You define on your repository method, you say, okay, it's async, it's a plain async annotation from Spring. And you say, okay, please return a completable future of list of customer. And with that, I can then go on and call this repository finder method, and I'm free to combine any additional processing, which can also be done asynchronously as I wish, right? It's somehow similar to what we offer with streams, but this gives you more power about more asynchronous execution directly in another way, in another sense. I mean, I know that streams have also this parallel streams and so forth stuff where you can pass in the executor and the like, but this is another way, and this plays nicely in the efforts that currently go into Spring Framework 4.2, which also is our hard working on providing support for completable futures, to give you some kind of minimalistic, maybe a little bit even reactive, fluent asynchronous execution model, without the back pressure stuff and all the like, but nevertheless, you can chain asynchronous computations and executions with that quite easily, right? And maybe the biggest new kid on the block is our support for Spring Data Key Value, which is basically a new project which is about providing a Spring Data repository backed by some kind of key value store, like a plain concurrent hash map or Hazelcast or what have you, right? And that's what I quickly want to show you. It has some base abstractions like a key value repository and a key value template. And in order to make it work with several different key value stores, you have to write a key value adapter. And with that, there is also a key query engine interface that you can implement if your data store has some support for some kind of query language besides find all, get by ID, and something like that, right? And currently, we actually have a map key value adapter, for instance, that can be used to get a Spring Data repository backed by a map, which is quite handy for tests and the like, or for caches even. And we also have found some nice way of being able to express queries via spell expressions. By letting you specify a predicate as a spell expression, and this spell expression we can then use to evaluate on the bunch of records, and whenever the predicate evaluates to true, we can collect the item and return it to you. So you have an easy means to do queries, which is, by the way, very generic, because the spell expression parser that we currently have in Spring provides you also with access to the underlying abstract syntax tree. And if you think about it, you can basically write a mechanism that lets your user specify arbitrary expressions with spell. Then you can transform the AST into every other query language that you want, right? So for instance, I use that for Spring Data MongoDB to make it easier to define arithmetic expressions, right? Who of you has already used, is working with MongoDB somehow? Okay, quite a few. So you probably used somehow arithmetic expressions in your code somewhere, and you know that's quite ugly to specify all the infix expression tree yourself as a JSON tree structure. And in Spring Data MongoDB, we enable you to just specify arbitrary arithmetic computations as a normal infix expression, like you would normally do as a sane human person. And then under the hood, we will translate that to the upright representation. So, and I think that's a pretty generic concept that can be used in many other projects or many areas as well. Just use spell as your interface of your generic language and transform the AST into everything you need. But just as a hint. So I have an example for that, of course. Let me just switch the IDE here. Whoop. Okay. Turns out. Okay, here we are. I think you can you read that? So okay, this is the this is an example for the map-based repository. So again, I just specify. Again, I'm using Lombok here to not show you too much code. I have a person entity. I declared an ID, which is a Spring Data ID annotation in this case. I define a person repository, X and CRUD repository. With that, I get all these mentioned CRUD functionality here, like where it is. Zoom in. I get count, find all, delete all, and what have you, already ready for you to use. Yeah, then I say, okay, in a plain Spring Boot application, I say enable map repositories. And there I say, okay, give me an instance of this person repository, and here you can say save, blah, and I can call find all, and I can also invoke my custom finder method, which effectively, based on that method, in this case of the map repositories, we generate a spell expression and then turn that spell expression into the right predicate that we use to filter that stuff. And yeah, it really works. If I run that, you see first the list of all persons that are registered here, and then the list of persons that are filtered for that particular value. That's basically it. So, and it makes it really easy to use it. And by the way, the dependency you have to declare in order for that to use is just here, Spring Data key value, right? Which comes if you refer to the latest Spring Boot parent and so forth. So it's quite easy to use. Okay, let's go back. So, hello, where are we? Okay, go back. Whoop. Okay, here we are. So, I just showed you that stuff already. So, here's again on the slides. All you have to do is quite easy. And yeah, some additional themes for Gosling are, if it comes, next one, are support for QueryDSL 4. I don't know whether you, for those of you who use QueryDSL, the core, the main developer of QueryDSL actually changed jobs, and therefore the QueryDSL project, the new version, can't use the old package names anymore, the common MySysma or what it was. So if you want to upgrade to QueryDSL 4, it could happen that you have to change some more code as you would usually have to change because the package names have to be different, right? That is something that you have to keep in mind. Yeah, for the Gosling release, which is basically scheduled for August, right before the Spring 1 conference this year, we are planning to provide support for Redis cluster, which is actually already almost there in the M1 release of Gosling. We provide the set support of for dynamic JPA fetch graphs in a declarative style, computer for future support. We are working on a way to provide you with reactive repositories. We are currently experimenting with a lot of different approaches, what might work best here. I have some examples that, just use structures from RxJava or plain reactive streams abstraction that you can then consume, but we are not decided on a final API yet. Yeah, some additional spell enhancements. So for instance, that you can also have this spell-based filtering mechanism in Spring Data MongoDB. That's actually something that I did last weekend. That's already working fine. And yeah, what else? It will, the next framework, next Spring Data release will be based on a Spring Framework 4.1 release. So currently we have as a baseline Spring 4.x, Spring 4.0 something, and yeah, we will raise that to the latest Spring 4.1 base in order to benefit from some enhancements in there as well. Yeah, we also feature a new thing called dynamic projections. So, for instance, imagine you have with Spring Data built a REST API with Spring Data REST, and you have your domain object, domain classes, like a person that has 20 attributes, right? But for a certain REST API method that you want to expose, or for a certain resource, for a certain operation, you just want to expose 2 properties of that, 20 or so, right? How do you do that? Well, you could implement some kind of transfer objects yourself and so forth, but we figured out that, well, we could do it far easier by just letting you provide an interface with some getters and setter methods that match the properties of your actual domain class. You say, okay, this is an excerpt or projection for a person class, for instance, and yeah, we can then link that projection class that you just defined to the appropriate REST controller method. So if you return in your REST controller something like a list of person projections, right, just the interface, and if you do via the Spring Data repositories, for instance, do a find all on all persons, which returns you the full object, but will then automatically transform those objects into some kind of proxy that we generate on the fly, but in an efficient way. And this proxy will basically implement your projection interface and delegate all getters and setter calls to the underlying real domain object instance, right? And this basically exposes only the properties that you specified on the projection interface to the serialization mechanism that you use, Jackson or whatever, right? And with that, you can really customize the views that your clients have on your domain objects in an easy way, right? Without writing real boilerplate transfer objects anymore. Just define interfaces, and that's all you need. Yeah, that's basically all I want to show you today. Yeah, if you have any questions, I will be at the booth for some time, and yeah, just come by and feel free to ask anything you'd like to know. And yeah, then thank you very much for your patience. So that we have 2 minutes left, so if maybe you can take one or two questions, if someone has one, okay?
Is there a support for aggregating queries, like sum, average, and so on?
Well, for across all data stores, no. There's store-specific. You can of course always write store-specific queries via the approach that I showed you, but we currently don't have that. But you can easily have that already if you just, for instance, return a stream of something, or a stream of int even, if you just query for an int, or a double, or a certain, you just traverse a field in your object graph via the query derivation mechanism, and yeah, just return a stream of doubles, and then you can say dot sum or something like that, right, on the stream resultant. So there's somehow not immediate support, but indirect support for that already. But okay, if you have some ideas how that might look like or what you actually want to do, I think we already have a Jira for that. Maybe you can just check that issue out and just add your comments there. But we are always open for such new features. But in order to implement them properly, we need real use cases. We actually generally have to take the approach that we only provide such abstractions for all data stores if we first find an efficient way to do it for all stores, and it is a high demand for it, because there are also a lot of other features that we have to channel in somehow, and yeah, we have to prioritize here. So, but yeah, if you have some cool use cases that could help us with this prioritization thing, we are very open to hear them. Okay. Any other question?
Can you point out to this benchmarking project that you use in Spring Data?
Okay. It's in the test, I think. Spring MongoDB. I will mark. Ooh. Font. Spring data MongoDB. GitHub. Okay. I will switch. This one. I think the stuff that they ran were here in the tests. Java performance, and here you find the stuff.
This is for Mongo and for
This is for Mongo. There is at the appropriate location in the Spring Data Commons or Spring Data JPA, there's a similar benchmark which effectively does the same, queries for all objects and the like. I mean, I can show it to you in a bit at the booth if you want, and we can have a look. Okay, any other question? Okay, so then I think we are done. Thank you very much.